In this video, we are going to do homework 4.9 day 2 together. So if you could please open that up, go into your iMath, find homework M for day 2. Now, the first thing that it says in problem number 1 is that an 11-inch sunflower is planted in a garden and the height of the sunflower increases daily at a continuous growth rate of 16%. So what we know is that, remember your formula we want to use, it's going to be our starting value, our day 1 growth. You remember we have to compare that to 100%, and then our time. Okay. So for A, I'm going to put f of t equals 11. Now it's going up by 16%. And it says continuous. I'm so sorry. So continuous, this would be if it was a percent, and they didn't mention the word continuous, just if they said exponential. And sorry, my pencil died. So we want to use this equation. We'll actually put a little p here for that PERT formula. That p can be our starting value. So it's going to be 11 e to the 0.16 t. So we use the rate exactly as is for our PERT formula. Okay. So that's what we're going to enter into this right here. Now, part B says, how many days after it's planted will the sunflower be 40 inches tall? So we want to know when this equation will equal 40. So remember, whatever number is here, we got to divide off. So it's 40 divided by 11 equals e to the 0.16 t. Now, the opposite of an e is a natural log. So if you stick a natural log over here, it will equal the power. And so we just need to divide this whole thing. We're going to have to enter that whole thing divided by 0.16. So that should go right there. So it's the natural log of the fraction, 40 over 11 for me. Now I need to all divide that entire thing. So I'm going to put parentheses around the whole thing, divided by 0.16. Okay, now it says, how many days after it was planted will the sunflower be 192 inches tall? So do you see what we've got over there to the right here, in this spot right there? See, the only thing that's different between this equation here where the 40 is sitting, just replace it with 192. So we're going to write for that portion, for C, it would be the natural log of 192 divided by 11 all over 0.16. So use what you've already calculated to help you move on. Okay, and I'm not going to take the time to type that. You take the time to type yours. And now I want to jump to question number 2. So I'm just going to help you set up your function, and then hopefully you get the idea of how to solve it, okay? So for part A, it says, write a function that determines the world population in billions in terms of years since 2018. So in 2018, it was 9 billion. It was growing by 1.2%. So our formula is going to be 9 times continuous growth. So it's going to be E to the rate 0.012 t. Okay, so that's what we're going to enter here. I'm going to put that entire thing, the power, in parentheses. So for me, I'm putting 0.012 t in the parentheses. And that should be my answer for part A. Now, once you know your formula is right, for B, when will it be 13? So 13 billion equals 9 e to the 0.01 t, 2t. So you're just going to put, after you divide by 9, the natural log goes where the e, on the other side of where the e was. So that'd be the natural log of 13 over 9 equals 0.012 t. Now don't forget, you have to divide both sides by 0.01 t. Now for D, it says the doubling time. So just take your 9 billion and turn it into 18 billion and do the math. Okay, so for C, you do 17.5. For D, you do the double of what you started with. So 9 becomes 18. Okay, so that is question 2. Do we have to do anything differently? Nope. Question 3 is the same. Question 4 is the same. Now, this is a continuous decay, so I want to do question number 5 with you. So if it says that it is decaying, the only difference in what we did for questions 1 through 4 is we want to use a negative rate. So for part A here, the function is going to be f of t is the starting amount, 29 grams, e to a power of negative 0.065 t. So that is your formula for A. So what is the half-life? So you got to think to yourself, for B, we started with 29. If I divide that by 2, that means my amount is 14.5. So just put in that half amount and do the math, okay? And so 14.5 divided by 29 equals e to the negative 0.065 t. That's 1/2. We did that on purpose. So we would get the natural log of 1/2 is negative 0.065 t. So if we want to calculate that, don't forget to solve for t. It would be the natural log of 1/2 divided by negative 0.065. Okay. Now for C, instead of 14.5, do the exact same thing with 5. For D, do the exact same thing, but use 16 in the 14.5 spot. So if it mentions decay, make sure that you use a negative rate. And then I want to do question 6 with you. For question 6, it says the half-life of a radioactive substance is the amount of time required for half of its mass to decay. The half-life of lead is 22.3 years. What is the continuous annual decay rate of lead? So let's just think what we know. Let's say we started out with 100 grams of lead. We know that after 22.3 years, we have 50 grams of it. So it could be any two amounts. I like using 100. 100's helpful. And so what I know is that if I start out with 50 and I go e to some negative, or some rate, the negative will pop out in the formula, some rate at a time of 22.3 years, I should have, okay, so if I start out with 100, I should end up with 50. Or e to that rate times 22.3 should be 1/2. So change that into a natural log. So r times 22.3 should equal the natural log of 1/2. So our rate is the natural log of 1/2 divided by 22.3. Now it says to type in the exact answer. So that's exactly what I'm going to type in, that the natural log of 1/2 is going to be divided by, let's put parentheses around the entire thing. I'm going to divide that by 22.3. And there we go. So there is the homework for 4.9 day 2. And then after this, we need to start reviewing for the test. So there you go.